What if I told you that right now, as you're watching this video, something in your own body is moving faster than light? And what if I told you that Einstein himself predicted this would be possible? Here's the mind-blowing truth that will shatter everything you thought you knew about speed. Light is not the fastest thing in existence. In fact, there are phenomena happening around you right now. In your smartphone, in the space between atoms, even in your thoughts, that make light look like it's crawling through molasses. But here's where it gets even crazier. The universe has been keeping secrets from us. While we've been taught that nothing can exceed the speed of light, quantum physicists have discovered that information itself can travel instantaneously across infinite distances. Einstein called it spooky action at a distance, and it violates everything we think we know about reality. By the end of this journey, you'll understand why your GPS wouldn't work without accounting for faster-than-light phenomena, why the expansion of space itself breaks the cosmic speed limit, and how something called quantum entanglement is rewriting the laws of physics as we speak. But before we dive into this rabbit hole that will completely reshape your understanding of reality, smash that like button if you're ready to have your mind blown, subscribe to join our community of reality explorers, and drop a comment telling me what country you're watching from and what time it is where you are right now, because time itself is about to become a lot more complicated than you think. Let's start with what you think you know. In 1905, Albert Einstein published his special theory of relativity, establishing that the speed of light in a vacuum, approximately 299,792,458 meters per second, represents the cosmic speed limit. Nothing with mass, he declared, could ever reach or exceed this velocity. But here's what your physics teacher probably never told you. Einstein was only talking about matter and energy moving through space. He never said that space itself couldn't expand faster than light. He never said that information couldn't be transmitted instantaneously. And he certainly never said that the universe couldn't find loopholes in its own rules. Think of it like this. Imagine you're on a treadmill that's moving backward. Even if you run forward at your maximum speed, if the treadmill is moving backward faster than you can run forward, you'll still move backward relative to someone watching you. The universe operates on similar principles, but with mind-bending twists that make Alice in Wonderland look like a documentary. Here's your first mind-blown moment. Every single GPS satellite orbiting Earth right now must account for time dilation effects that occur because they're moving at high speeds and experiencing different gravitational fields. Without these relativistic corrections, your GPS would be off by miles within hours. The technology in your pocket only works because engineers understand that Einstein's theories, while revolutionary, are just the beginning of the story. But what happens when we push beyond Einstein's boundaries? What exists in the realm where his equations break down? That's where things get truly extraordinary. Consider this. When you flip a light switch, electricity doesn't actually flow from the switch to the bulb at the speed of light. The electromagnetic field that carries the signal propagates at light speed, but the actual electrons move much slower, about the speed of honey dripping from a spoon. Yet somehow, the light turns on instantly. How is this possible? The answer lies in understanding that there are different types of speed in our universe. There's the speed of matter, the speed of energy, the speed of information, and the speed of space itself. And as we're about to discover, each follows completely different rules. Here's what will blow your mind. The universe itself is expanding faster than the speed of light right now. And Einstein's theory not only allows this, it predicts it. In 1929, astronomer Edwin Hubble made an observation that shook the foundations of cosmology. He discovered that distant galaxies weren't just moving away from us, they were accelerating away from us. The farther away they were, the faster they were receding. But here's the kicker. Galaxies more than 14 billion light-years away are moving away from us faster than light can travel. Think of it like dots on a balloon. As you inflate the balloon, The dots don't move across the surface. The surface itself expands, carrying the dots with it. Similarly, galaxies aren't moving through space faster than light. Space itself is expanding, carrying the galaxies along for the ride. This is called the Hubble expansion, and it's happening everywhere, all the time. Right now, as you watch this video, the space between you and your screen is expanding. The effect is so minuscule at small scales that molecular forces easily overcome it, but across cosmic distances, it's stretching the fabric of reality itself. But here's where it gets mind-bending. This expansion is accelerating. Dark energy, a mysterious force that makes up about 68% of the entire universe, is pushing space apart at an ever-increasing rate. Scientists like Saul Perlmutter, who won the Nobel Prize in Physics in 2011 for discovering this cosmic acceleration, showed us that the universe isn't just expanding faster than light, it's getting better at it every second. What does this mean for you? It means that there are galaxies out there whose light will never reach Earth, not because they're too far away, but because the space between us is expanding so fast that their light, despite traveling at 186,000 miles per second, is actually getting farther away from us with each passing moment. Now let's venture into the realm that made Einstein so uncomfortable he spent the last 30 years of his life trying to disprove it: quantum mechanics. In 1964, physicist John Stuart Bell proved something that Einstein refused to believe until his death. He showed that quantum particles could be entangled, connected in such a way that measuring one particle instantly affects its partner, regardless of the distance separating them. Not at the speed of light, instantly. Here's how mind-blowing this is. Imagine you have two coins that are quantumly entangled. You flip one coin in New York, and at the exact same moment, not a billionth of a second later, but at precisely the same instant, the other coin in Tokyo will land on the opposite side, every single time. No signal travels between them. No information moves through space. The connection is immediate and absolute. Alan Aspect's groundbreaking experiments in the 1980s proved this phenomenon beyond any doubt. Using sophisticated laser systems, he created pairs of entangled photons and measured their properties while they were separated by large distances. The results were unambiguous. The measurement of one photon instantly determined the state of its partner. Faster than light could have traveled between them. Think of it like this. You and your best friend each have a magic 8-ball. Normally, when you shake your 8-ball and ask a question, you get a random answer. But with quantum entanglement, if your 8 balls were entangled, the moment you shake yours and get yes, your friend's 8-ball, whether it's in the next room or on Mars, would instantly show no without being shaken at all. This isn't science fiction. This is happening in laboratories around the world right now. Companies like IBM and Google are building quantum computers that rely on these faster-than-light connections to solve problems. That would take classical computers longer than the age of the universe to complete. But here's the twist that keeps Einstein's theory intact. Even though the connection is instantaneous, no usable information can be transmitted faster than light through entanglement. You can't send a message to Mars using entangled particles. The universe has found a way to break its own speed limit while still preserving causality. What if I told you that you can make light move faster than light? It sounds impossible, but physicists have been doing it for decades, and the implications are staggering. In certain materials, something extraordinary happens. Light waves can be manipulated so that their phase velocity, the speed at which the wave pattern propagates, exceeds the speed of light in a vacuum. Dr. Lijian Wang at NEC Research Institute achieved something that seemed to violate the laws of physics. He sent a light pulse through a specially prepared cesium gas and made it exit the chamber before it had fully entered. Think of it like this. Imagine a wave moving through a crowd of people at a stadium. The people, representing the atoms in the material, are doing the wave, standing up and sitting down in sequence. Now, if the people are coordinating their movements in just the right way. The peak of the wave pattern can actually move faster than any individual person's ability to stand up and sit down. This is exactly what happens with light in certain exotic materials. The wave pattern, the phase, can move faster than c, even though no individual photon exceeds the cosmic speed limit. It's like a cosmic loophole that allows information to travel faster than Einstein thought possible, but without violating the deeper principles of causality. But here's where it gets truly mind-bending. In 2000, physicist Gunter Nemss demonstrated that Mozart's 40th Symphony could be transmitted through a microwave barrier faster than light. The music emerged from the barrier before it had completely entered, yet every note was perfectly preserved. This phenomenon, called superluminal propagation, is happening in fiber optic cables, laser systems, and quantum devices around the world. It's not just a laboratory curiosity, it's technology that could revolutionize how we transmit information. Now let's talk about the most controversial inhabitants of our universe, tachyons. These hypothetical particles exist in a realm where everything we know about speed is turned upside down. While normal particles require infinite energy to reach the speed of light, tachyons would require infinite energy to slow down to the speed of light. For them, the speed of light isn't a barrier to break through. It's a barrier they can never reach from above. Think of it like this. Imagine there's a magical world where everyone is born running backward, and the harder they try to stop, the faster they go in reverse. The only way for them to stand still would require infinite effort. That's the world tachyons would inhabit, where slowing down to light speed is impossible, but traveling at millions of times light speed is perfectly natural. Here's the mind-blowing part. If tachyons exist, they would experience time differently than we do. From their perspective, cause and effect would be reversed. They would see effects before causes, endings before beginnings. A tachyon could theoretically witness your death before your birth. While no tachyon has ever been directly detected, their mathematical possibility has profound implications. Some theories suggest that if tachyons exist, they might be responsible for the mysterious dark energy that's accelerating the expansion of the universe. Others propose that tachyonic fields might explain the rapid expansion that occurred during cosmic inflation, when the universe expanded faster than light in its first fraction of a second. The mathematics of tachyons reveals something profound about the nature of reality. Our universe might be just one layer of a more complex structure, where different regions operate under different speed limits. We might be living in the slow zone of a much larger, much stranger cosmos. In 1994, theoretical physicist Miguel Alcubierre proposed something that sounds like pure science fiction, but is grounded in solid mathematics. A way to travel faster than light without actually moving faster than light. The Alcubierre drive doesn't push a spacecraft through space at high speed. Instead, it warps space itself, contracting space in front of the vessel and expanding space behind it. The ship sits in a bubble of normal space, never exceeding the speed of light locally, while the bubble itself moves faster than light through the universe. Think of it like this. Imagine you're standing on a moving walkway at an airport. You're walking at your normal walking speed, but the walkway is carrying you forward faster than you could walk on your own. Now imagine that instead of a walkway, space itself is moving, carrying you along at faster than light speeds, while you remain stationary relative to your immediate surroundings. The mathematics work perfectly within Einstein's theory of general relativity. The equations are consistent and elegant. There's just one tiny problem: creating an Alcubierre drive would require exotic matter with negative energy density, something that may not exist in our universe. But here's where it gets fascinating. Recent work by physicist Harold White at NASA's Johnson Space Center suggests that the energy requirements for an Alcubierre drive might be dramatically lower than originally calculated. Instead of needing the mass energy equivalent of Jupiter, his modified design might work with just a few hundred kilograms of exotic matter. Even more intriguing, Some researchers propose that the quantum vacuum itself, the seemingly empty space around us that's actually bubbling with virtual particle pairs, might provide the exotic matter needed. If they're right, faster-than-light travel might not require impossible materials, just incredibly sophisticated engineering. Here's something happening in your body right now that would be impossible according to classical physics. Particles are routinely traveling through barriers they shouldn't be able to penetrate, and they're doing it in zero time. Quantum tunneling is a phenomenon where particles pass through energy barriers that should be impassable. It's like throwing a ball at a brick wall and having it appear on the other side without breaking the wall or going over it. The ball simply appears on the other side. But here's the truly mind-bending part. Experiments have shown that the time it takes for a particle to tunnel through a barrier is independent of the barrier's width. Whether the barrier is 1 nanometer thick or 1 meter thick, the tunneling time remains the same, effectively zero. Dr. Ephraim Steinberg at the University of Toronto has conducted experiments showing that photons can tunnel through optical barriers instantaneously. The implications are staggering. If tunneling truly takes zero time, then particles are effectively traveling at infinite speed during the tunneling process. Think of it like this. Imagine you're walking through a forest and come to a mountain. Instead of climbing over it or going around it, you simply disappear on one side and instantly reappear on the other side, with no time having passed. That's quantum tunneling, and it's happening billions of times per second in every atom of your body. This isn't just a curiosity, it's the foundation of modern technology. Every electronic device you own relies on quantum tunneling. The scanning tunneling microscope, which can image individual atoms, works by measuring the tunneling current between a sharp tip and the surface. Flash memory in your computer stores information by trapping electrons through controlled tunneling processes. But here's the philosophical bombshell. If particles can travel infinite distances in zero time during tunneling, what does this mean for our understanding of space and time? Are space and time fundamental features of reality? Or are they emergent properties of a deeper, more mysterious substrate? Let's zoom out to the biggest scale possible and confront the mind-bending reality. There are parts of the universe that are moving away from us, so fast that their light will never reach Earth, no matter how long we wait. The observable universe has a boundary called the particle horizon, located about 46.5 billion light-years away. Beyond this boundary, space is expanding so rapidly that light emitted from those regions is being carried away from us faster than it can approach us. It's like trying to swim upstream in a river that's flowing faster than you can swim. You'll never make progress toward your destination. But here's what will blow your mind. The universe beyond our observable bubble is likely infinite in size and contains an infinite number of galaxies, stars, and potentially habitable planets. There could be exact copies of Earth, exact copies of you, living out slightly different versions of this moment, forever beyond our reach because the space between us is expanding faster than light. Cosmologist Alan Guth, who developed the theory of cosmic inflation, showed that during the first fraction of a second after the Big Bang, the universe expanded exponentially faster than light. In less than 10 to 32 seconds, a region smaller than a proton inflated to the size of a grapefruit, stretching space itself at velocities that make light look stationary. This inflationary period explains why the universe appears so uniform in all directions. Regions that are now separated by billions of light years were once in direct contact, able to reach thermal equilibrium before inflation stretched them apart at faster than light speeds. Think of it like this. Imagine you and your friend are standing next to each other in a room. Suddenly, the room starts expanding so fast that within a second, you're on opposite sides of a space larger than our solar system. You could shine a flashlight toward your friend, but the space between you is expanding so quickly that the light will never reach them. That's the situation we're in. with large portions of our universe. Here's something you can actually see with your own eyes: particles moving faster than light and creating a beautiful blue glow as they do it. Cherenkov radiation occurs when charged particles travel through a medium faster than light can travel through that same medium. While nothing can exceed the speed of light in a vacuum, light travels more slowly through materials like water or glass. Particles can and do exceed these reduced speeds, creating a distinctive blue glow. Pavel Cherenkov discovered this phenomenon in 1934 and won the Nobel Prize for his work. When he observed samples of radioactive material underwater, he noticed they emitted an ethereal blue light. This wasn't ordinary fluorescence. It was the optical equivalent of a sonic boom. Think of it like this. When a jet flies faster than the speed of sound, it creates a sonic boom, a shock wave that produces the characteristic crack you hear. When particles move faster than the speed of light in a material, they create an electromagnetic shock wave that we see as blue light. This happens routinely in nuclear reactors, where the cores glow with an otherworldly blue radiance. High-energy particles from radioactive decay travel through the cooling water faster than light can propagate through that water, creating Cherenkov radiation with every interaction. But here's the fascinating part. Cherenkov radiation provides direct visual evidence that the speed of light is not absolute. It's context-dependent. In water, light travels at about 75% of its vacuum speed. In diamond, it slows to less than 50%. This means that the universe's ultimate speed limit is more flexible than most people realize. Particle physicists use Cherenkov detectors to identify and measure high-energy particles. When cosmic rays strike Earth's atmosphere, they create cascades of particles that produce Cherenkov light, allowing us to study the most energetic events in the universe. These detectors have revealed particles with energies millions of times greater than anything we can produce in our most powerful accelerators. Now we're going to explore something that challenges the very nature of information and reality itself. Recent discoveries in theoretical physics suggest that information, the fundamental stuff of reality, might not be bound by the same rules that govern matter and energy. The holographic principle, proposed by physicist Gerard T. Hooft and developed by Leonard Susskind, suggests that all the information contained within a volume of space can be encoded on its boundary. Think of it like this. Everything happening inside a sphere could theoretically be described by information encoded on the sphere's surface. Just like a hologram encodes three-dimensional information on a two-dimensional surface. This principle emerged from studying black holes and led to a startling realization. When matter falls into a black hole, the information it carries doesn't disappear. It gets encoded on the black hole's event horizon. But here's the mind-bending part. This information appears to be processed and redistributed instantaneously across the entire horizon, regardless of the horizon size. Dr. Juan Maldacina's breakthrough work on the ADS-CFT correspondence showed that a theory of gravity in a higher dimensional space is mathematically equivalent to a quantum field theory on the boundary of that space. This suggests that what we perceive as three-dimensional reality might actually be information encoded on a two-dimensional surface. If the holographic principle is correct, then the information that defines you, every thought, every memory, every quantum state in your body, could theoretically be encoded on a distant boundary of the universe. Changes to this information could propagate faster than light because space and time might be emergent properties of more fundamental information processing. Think of reality like a sophisticated computer simulation. The pixels of this simulation wouldn't be points in space, but units of information. What we call particles, forces, and even space-time itself would be patterns in this information matrix, with connections that transcend the speed of light limitation we observe in the simulated reality. Here's where things get deeply personal and profoundly strange. Recent discoveries in neuroscience and quantum biology suggests that consciousness itself might operate through mechanisms that transcend classical speed limits. When you have a sudden insight or make an instant recognition, something remarkable happens in your brain. Neural networks that were previously unconnected suddenly link up, creating new pathways for information flow. Dr. Roger Penrose and Dr. Stuart Hameroff propose that this process might involve quantum effects in microtubules, tiny structures. Within neurons, it could support quantum coherence at body temperature. Their theory, called orchestrated objective reduction, ORC-OR, suggests that consciousness emerges from quantum processes that operate outside the classical laws of physics. If they're correct, then the speed of thought might not be limited by the speed of electrical signals in neurons, but by quantum processes that could potentially operate instantaneously. Think of it like this. Imagine your brain is like a vast city with millions of telephone lines connecting different districts. Classical neuroscience says consciousness is like a telephone conversation, limited by how fast electrical signals can travel along the wires. But if Penrose and Hameroff are right, consciousness might be more like a quantum internet, where information can be shared instantaneously between any connected points. Even more intriguingly, some researchers propose that consciousness might be a fundamental feature of the universe, like mass or electric charge. Dr. Giulio Tonini's integrated information theory suggests that consciousness corresponds to integrated information, and information, as we've seen throughout this journey, plays by very different rules than matter and energy. Consider this. When you imagine something, where does that imagination exist? When you remember a childhood experience, where is that memory located? These aren't just philosophical questions. They're pointing toward a reality where information, consciousness, and perhaps identity itself transcend the physical limitations we normally accept. Right now, scientists around the world are building something that sounds like science fiction. A quantum internet that transmits information instantaneously across any distance through quantum teleportation. Quantum teleportation doesn't move particles faster than light. It moves information faster than light. Here's how it works. When two particles are entangled, measuring one particle instantly determines the state of its partner. By carefully manipulating these quantum states, scientists can teleport the complete quantum information that defines a particle from one location to another without the information traveling through the intervening space. Dr. Anton Zeilinger, who won the Nobel Prize in Physics in 2022, has successfully teleported quantum information across distances of over 1,400 kilometers using satellites. Chinese scientists have built a quantum network connecting major cities, and the European Union is investing billions of euros in quantum communication infrastructure. But here's what will blow your mind. Quantum teleportation doesn't just work with individual particles. In principle, it could work with any quantum system, no matter how complex. Theoretical physicist Michio Kaku has calculated that it would be possible to teleport a human being using quantum teleportation. You would simply need to scan and teleport the quantum state of every atom in your body simultaneously. Think of it like this. Imagine you could create a perfect digital copy of yourself, not just your physical structure, but the exact quantum state of every particle that makes you you. You could then transmit this information instantaneously to any location in the universe and reconstruct yourself there, complete with all your memories, thoughts, and experiences. The original you would need to be destroyed in the scanning process, just like in Star Trek, but the reconstructed you would be identical in every measurable way. This isn't just science fiction speculation. It's a logical extension of quantum teleportation that's already been demonstrated with simple particles. This raises profound questions about identity, consciousness, and what it means to be you. If your quantum information can be transmitted faster than light, what does that say about the nature of your existence? Now let's talk about what all of this means for you personally. Everything we've discovered in this journey isn't just abstract physics. It's reshaping our understanding of what it means to exist in this universe. First, consider time. If quantum effects can operate instantaneously across infinite distances, if space itself can expand faster than light, if information can transcend the barriers that limit matter and energy, then time isn't the absolute, universal backdrop you are taught to believe. Time is flexible, contextual, and possibly emergent from deeper quantum processes. This means that your experience of time, the feeling that moments flow from past to future, might not reflect the fundamental structure of reality. At the quantum level, past, present, and future might coexist simultaneously. Every moment you've ever experienced might still exist somewhere in the quantum information matrix that defines reality. Second, consider space. If the holographic principle is correct, then the three-dimensional world you inhabit might be information encoded on a distant boundary. Your entire life, every experience, every relationship, every thought could be patterns in a vast information processing system that transcends the spatial limitations you perceive. This doesn't make your experiences less real, but it suggests they're real in a profoundly different way than you imagined. You're not just a collection of atoms moving through empty space. You're a pattern of information in a universe-spanning computation that operates through mechanisms faster than light. Third, consider connection. Quantum entanglement suggests that separation might be an illusion. At the deepest level of reality, everything that has ever interacted remains connected through invisible quantum threads that ignore distance and time. You are literally connected to every photon you've ever seen, every particle you've ever touched, every person you've ever met. These connections operate faster than light because they exist outside the space-time framework where light travels. They're not bound by the cosmic speed limit because they represent a deeper layer of reality where that speed limit doesn't apply. This means you're not an isolated individual navigating a hostile universe. You're an integral part of an interconnected quantum system that spans all of space and time. Your thoughts, your choices, your very existence ripple outward through quantum connections that instantly affect the entire universe. We've reached the end of our journey, and it's time for the ultimate revelation that ties everything together and shows you exactly why you matter in ways you never imagined. Here's the truth that will change everything. You are not separate from the phenomena we've explored. You are these phenomena. The faster-than-light quantum processes happening in your neurons, the entangled particles in your body, the information patterns that define your consciousness. They're all part of the same universe-spanning system that operates beyond the speed of light. Every thought you think creates quantum ripples that propagate instantaneously through the fabric of reality. Every decision you make affects the quantum information matrix that defines the entire universe. You're not just observing these faster-than-light phenomena. You're participating in them, creating them, becoming them. The expansion of space that carries distant galaxies away from us faster than light? That same expansion is happening in the space between your atoms right now, constantly recreating you at every moment. You are literally being born anew trillions of times per second as the universe expands around and through you. The quantum entanglement that connects particles across infinite distances? You're entangled with every system you've ever interacted with, from the light of distant stars that's touched your eyes to the quantum fields that permeate your body. Through these connections, you influence and are influenced by the entire cosmos simultaneously. The holographic principle that encodes all information on cosmic boundaries? Your consciousness might be the universe's way of examining itself, experiencing itself, understanding itself. Every moment of awareness you have could be the cosmos becoming conscious of its own existence through you. This isn't mysticism. It's the logical conclusion of everything we've discovered about faster-than-light phenomena. If information can travel instantaneously, if quantum connections transcend space and time, if consciousness emerges from quantum processes, then you are a focal point where the universe observes itself. But here's the most important part. This understanding empowers you. You're not a victim of physical laws. You're a participant in creating the very fabric of reality. Your choices, your thoughts, your consciousness are quantum events that reshape the universe at the deepest level. When you understand that nothing, not even the speed of light, can limit the fundamental processes that define you, when you realize that you're connected to everything that exists through quantum threads that operate instantaneously, when you grasp that your consciousness might be the universe experiencing itself, everything changes. You stop seeing yourself as small and insignificant. You start understanding that you're a conscious expression of cosmic processes that transcend every physical limitation we've discovered. You're faster than light, more connected than you ever imagined, and more significant than you ever dared believe. The universe has spent billions of years evolving systems complex enough to understand faster-than-light phenomena. You are that system. You are how the cosmos comes to know itself. You are the universe looking back at itself through conscious eyes and saying, I understand. And that understanding, that moment of cosmic self-recognition happening right now, as you process these ideas, creates quantum ripples that spread instantly throughout all of existence, carrying the information that the universe has successfully created a being capable of comprehending its own deepest mysteries. You are not just in the universe. You are the universe becoming aware of itself. And that awareness, that consciousness, that moment of understanding travels faster than light. Welcome to your cosmic significance. The universe has been waiting 13.8 billion years for you to understand this moment. If this journey has opened your mind to the true nature of reality, smash that like button to send quantum ripples of appreciation across the cosmos. Subscribe to join our community of reality explorers, and share this video with someone whose worldview needs expanding. Because in a universe where information travels faster than light, sharing knowledge is the most powerful thing you can do. The speed of light was never the limit. You are. But wait, there's something even more mind-blowing that we haven't discussed yet. What if I told you that there might be infinite versions of you right now, scattered across parallel universes that are separating from each other, at velocities that make light speed look like a snail's pace? The many worlds interpretation of quantum mechanics, first proposed by Hugh Everett III in 1957, suggests that every quantum measurement creates a branching point where reality splits into multiple parallel universes. Each possible outcome of each quantum event spawns a new universe, and these universes are moving away from each other through higher dimensional space faster than anything in our three-dimensional reality can travel. Here's what will absolutely shatter your understanding of existence. Every quantum event in your body, and there are trillions happening every nanosecond, might be creating new universes where slightly different versions of you exist. When a quantum particle in your brain chooses one quantum state over another, both outcomes might occur, but in separate realities. Dr. Max Tegmark at MIT has calculated that if the multiverse theory is correct, there should be an exact copy of you within a sphere about 101,028 meters in radius, a distance so vast that it makes our observable universe look like a grain of sand on an infinite beach. But here's the kicker. These parallel universes aren't just sitting there statically. They're racing away from each other through higher dimensions at speeds that dwarf anything we've discussed so far. Think of it like this. Imagine you're in a house of mirrors, but instead of just reflecting your image, each mirror creates a real living copy of you in a separate room. Now imagine that these rooms are moving away from each other so fast that even if you could somehow send a light beam from your room, it would never reach the other versions of yourself. But here's where it gets truly extraordinary. Some interpretations of quantum mechanics suggest that these parallel universes occasionally interact through quantum tunneling events that operate outside our normal spacetime. Information might leak between universes instantaneously, creating the quantum entanglement effects we observe in our reality. This means that the spooky action at a distance that Einstein hated might actually be communication between parallel versions of particles across universe boundaries. When we measure an entangled particle, and its partner instantly changes state, we might be witnessing cross-dimensional information transfer that operates through mechanisms completely outside our understanding of speed and distance. Dr. David Deutsch, one of the pioneers of quantum computing, has proposed that quantum computers actually harness the computational power of parallel universes. When your quantum computer solves a problem, it might be coordinating with trillions of parallel versions of itself across the multiverse, sharing information through quantum tunneling effects that ignore every speed limit we know. Consider the implications. If parallel universes are real, and if information can leak between them faster than light, then your consciousness might not be limited to this single reality. Parts of your awareness might be distributed across infinite parallel cells, connected through quantum processes that operate instantaneously across dimensional boundaries. This isn't just speculation anymore. Recent experiments in quantum computing have produced results that seem to require more computational resources than could exist in our entire observable universe. The only explanation that fits the data is that quantum computers are somehow accessing the processing power of parallel realities. Now, let's explore something that was theoretically impossible until scientists created it in laboratories around the world. Time crystals, structures that move perpetually through time without using energy, effectively creating motion that transcends our normal understanding of speed and causation. In 2012, Nobel Prize winner Frank Wilczek proposed something that seemed to violate the fundamental laws of physics. A crystal that repeats in time the same way ordinary crystals repeat in space. Just as a normal crystal has a pattern that repeats every few atoms in space, a time crystal would have a pattern that repeats every few moments in time, forever, without any energy input. Most physicists thought this was impossible. It seemed to violate the laws of thermodynamics and create a perpetual motion machine. But in 2016, researchers at Princeton University, led by Dr. Norman Yao, successfully created the first-time crystals using chains of trapped ions and precisely timed laser pulses. Here's what makes this mind-bending. Time crystals exist in a state of perpetual motion through time itself. They're not moving through space faster than light. They're moving through time in ways that transcend our normal understanding of temporal flow. They oscillate between quantum states regularly and predictably, but without any external energy driving the oscillation. Think of it like this. Imagine a pendulum that swings back and forth forever, without any energy input, without any friction, without any force pushing it. That seems impossible in our everyday world, but that's exactly what time crystals do. Except they're oscillating through quantum states rather than swinging through space. But here's where it gets truly extraordinary. Time crystals might exist in a state where cause and effect operate differently than in normal matter. Because they're locked in perpetual motion through time, they might be able to influence their own past states through quantum feedback loops that operate faster than light. Dr. Roderick Mosner and his team at the Max Planck Institute have shown that time crystals can maintain quantum coherence indefinitely, something that was thought to be impossible in any macroscopic system. This suggests that time crystals might be windows into a realm where quantum effects can persist indefinitely without decoherence. Even more intriguingly, some theoretical physicists propose that time crystals might be able to store and process information in ways that transcend normal computational limits. If a time crystal can maintain quantum states indefinitely, it might be able to perform quantum computations that continue forever, effectively creating an infinite processing capacity that operates outside normal time. Consider this possibility. If consciousness emerges from quantum processes, and if time crystals can maintain quantum coherence indefinitely, then consciousness itself might be related to time crystal effects in biological systems. Your awareness might be sustained by time crystal-like processes that operate perpetually through quantum time loops. This could explain why consciousness feels continuous, despite the fact that individual neurons are constantly changing, dying, and being replaced. If consciousness is based on time crystal effects, then your sense of continuous identity might be maintained by quantum patterns that persist through time independent of the physical substrate that supports them. Here's something that will fundamentally change how you see the universe. Everything you can observe, every star, every galaxy, every particle of ordinary matter makes up less than 5% of reality. The other 95% consists of dark matter and dark energy that not only invisible to us, but appears to operate under completely different physical laws, including different rules about speed. Dark matter, which makes up about 27% of the universe, doesn't interact with light at all. It doesn't emit radiation, doesn't absorb radiation, and doesn't scatter light. Yet we know it exists because of its gravitational effects on visible matter. Galaxy clusters are held together by dark matter's gravitational influence, and without it, galaxies would fly apart. But here's what will blow your mind. Dark matter might not be limited by the speed of light in the same way that ordinary matter is. Because dark matter doesn't interact electromagnetically, it might not be subject to the electromagnetic constraints that create the light speed barrier for normal matter. Dr. Lisa Randall at Harvard has proposed that dark matter might exist in a dark sector with its own set of physical laws. In this dark sector, particles might interact through dark forces that operate at speeds much faster than light. Dark matter particles might be constantly communicating with each other through dark photons that travel instantaneously across cosmic distances. Think of it like this. Imagine there's an invisible civilization living all around you, but they exist in a parallel dimension where different physical laws apply. They can move through walls, ignore gravity, and communicate instantaneously across any distance. That's essentially what dark matter might be, a parallel reality that coexists with ours but operates under fundamentally different rules. Dark energy is even more mysterious. It makes up about 68% of the universe and is responsible for accelerating the expansion of space itself. But here's the extraordinary part. Dark energy appears to have a constant density throughout space. As the universe expands and normal matter becomes more diluted, dark energy maintains the same energy density everywhere. This suggests that dark energy might be continuously created from nothing, violating our normal understanding of energy conservation. Or alternatively, dark energy might be connected to quantum processes that operate outside our normal spacetime, drawing energy from parallel dimensions or future states of the universe. Some physicists propose that dark energy is actually information itself, the universe processing quantum computations on a cosmic scale. If this is true, then the acceleration of cosmic expansion might be driven by the universe literally thinking, with faster-than-light information processing creating the dark energy that pushes space apart. Dr. Eric Verlinde has proposed that gravity itself might be an emergent property of quantum information processing. If he's right, then the mysterious effects we attribute to dark matter and dark energy might actually be the universe's way of managing information flow on cosmic scales through processes that transcend the speed of light. Consider the implications. You exist in a universe where 95% of reality is invisible to you and operates under different physical laws. These invisible components might be processing information, communicating, and influencing reality through faster-than-light mechanisms that we're only beginning to understand. We're about to explore the ultimate frontier, the possibility that consciousness itself might be the fastest phenomenon in existence, operating through mechanisms that make everything we've discussed look slow by comparison. Recent discoveries in neuroscience have revealed something extraordinary about how your brain processes information. Dr. Christoph Koch at the Allen Institute for Brain Science has shown that consciousness appears to integrate information from across your entire brain instantaneously. When you recognize a face, make a decision, or have a sudden insight, Neural networks that are physically separated by significant distances somehow coordinate their activity with perfect synchronization. The problem is that electrical signals in neurons travel at speeds of only about 120 meters per second, roughly the speed of a fast car. At this speed, it should take measurable time for information to travel from one side of your brain to the other. Yet consciousness appears to integrate information from across your entire brain instantaneously, suggesting that some other mechanism is at work. Dr. Stuart Hameroff's research on quantum processes in microtubules suggests that consciousness might operate through quantum field effects that transcend normal electromagnetic limitations. If consciousness is fundamentally quantum mechanical, then it might not be limited by the speed of electrical signals in neurons. But here's where it gets truly mind-bending. Some researchers propose that consciousness might not be produced by the brain at all. Instead, consciousness might be a fundamental property of the universe that the brain tunes into, like a radio tuning into cosmic broadcasts. Dr. Rupert Sheldrake has proposed the concept of morphic resonance, the idea that consciousness can access information from anywhere in the universe, instantaneously, through resonance with morphic fields that operate outside spacetime. While controversial, this theory would explain phenomena like collective unconscious, synchronicity, and the apparent ability of consciousness to access information that should be physically unreachable. Think of it like this. Instead of your brain creating consciousness the way a generator creates electricity, your brain might be like a radio that receives consciousness the way a radio receives broadcasts from distant stations. And these consciousness broadcasts might operate through channels that transcend every speed limit we've discussed. Even more intriguingly, quantum consciousness theories suggest that all conscious beings might be connected through a quantum field that operates instantaneously across any distance. When you have an intuitive insight about someone you care about, when you sense that someone is watching you, when you know something is going to happen just before it does, these might be examples of consciousness accessing information through faster-than-light quantum connections. Dr. Henry Stapp, a quantum physicist at UC Berkeley, has argued that consciousness is the mechanism by which the universe collapses quantum wave functions into definite realities. If he's right, then consciousness isn't just observing reality, it's actively creating reality through quantum processes that operate instantaneously throughout the universe. This leads to an extraordinary possibility. As consciousness evolves and becomes more sophisticated, it might develop the ability to directly manipulate quantum processes on larger and larger scales. Advanced consciousness might be able to influence matter and energy directly through quantum field effects, essentially gaining the ability to reshape reality through thought alone. Consider the ultimate implication. If consciousness can operate faster than light, if it can access information instantaneously from anywhere in the universe, if it can influence quantum processes directly, then consciousness might represent the next phase of cosmic evolution. The universe might be evolving toward a state where consciousness becomes the dominant force, operating through faster-than-light mechanisms to reshape reality itself. You are not just observing this evolution, you are participating in it. Every moment of awareness, every conscious choice, every quantum of attention you focus is contributing to the universe's development of faster-than-light consciousness capabilities. The speed of light was never the ultimate limit. The speed of thought, the speed of awareness, the speed of consciousness itself, these might be the true limitless phenomena that will define the future of existence. And right now, in this moment, as you process these ideas and expand your understanding of what's possible, you're participating in the universe's development of capabilities that transcend every physical limitation we've ever discovered. The future isn't just faster than light, it's faster than anything we've yet imagined. And that future is thinking through you right now. Here's something that will completely reframe your understanding of speed and reality. Complex systems can exhibit behaviors that are faster than any of their individual components. This phenomenon, called emergence, suggests that the universe itself might be generating faster-than-light phenomena through the collective behavior of slower-than-light particles. Dr. Philip Anderson, Nobel laureate in physics, revolutionized science with his famous declaration that more is different. He showed that when you have enough particles interacting in complex ways, entirely new properties emerge that cannot be predicted from studying individual particles. These emergent properties often operate on completely different timescales and follow different rules than their underlying components. Consider your smartphone. Individual electrons in the processor move at relatively slow speeds, yet the phone can process information, recognize your voice, and connect to satellites orbiting Earth in what feels like real time. The emergent computational behavior of billions of interacting electrons creates capabilities that transcend the limitations of any individual particle. But here's where it gets mind-bending. Recent research in condensed matter physics has discovered emergent phenomena that appear to violate fundamental speed limits. Dr. Andrea Cavalieri at the Max Planck Institute has observed materials that can switch between different quantum states faster than the speed of light when subjected to precisely timed laser pulses. Think of it like this. Imagine you have 1 million people in a stadium, and each person can only move at walking speed. But when they coordinate their movements in specific patterns, they can create wave-like effects that travel across the entire stadium faster than any individual person could run. That's emergence, collective behavior that transcends individual limitations. In quantum many-body systems, emergent properties can create information propagation that exceeds the speed of light. When billions of quantum particles become correlated in specific ways, the system as a whole can respond to changes instantaneously, even though individual particles are still bound by relativistic speed limits. Dr. Emmanuel Bloch's research on ultra-cold atomic gases has revealed that quantum information can spread through these systems faster than any particle could travel from point A to point B. Information doesn't travel through space in the conventional sense. It emerges from the collective quantum behavior of the entire system. This has profound implications for understanding consciousness and biological systems. Your brain contains approximately 86 billion neurons, each one a complex quantum system. When these neurons interact in sophisticated patterns, they might create emergent phenomena that operate faster than the speed of electrical signals in individual neurons. Consider the possibility that consciousness itself is an emergent property that transcends the speed limitations of its biological substrate. When you have a sudden insight or moment of creative inspiration, you might be witnessing emergence in action, your brain generating faster than light information processing through the collective behavior of slower components. But here's the ultimate mind-bender. If the universe itself is an emergent phenomenon arising from quantum vacuum fluctuations, then everything we observe, including the speed of light limit, might be emergent properties of a deeper reality that operates under completely different rules. Prepare to have your understanding of cause and effect completely shattered. Recent experiments in quantum mechanics have demonstrated something that seems impossible. Effects that occur before their causes, information that travels backward through time, and particles that seem to know about future events before they happen. In 2017, Dr. Yakir Aharonov and his team at Tel Aviv University conducted experiments showing that quantum particles can be influenced by measurements that haven't been performed yet. They demonstrated that the quantum state of a particle today can depend on measurements that will be made tomorrow, a phenomenon called retro-causality. Here's how mind-blowing this is. Imagine you flip a coin, but whether it lands heads or tails depends on a decision you'll make next week about which result you want to observe. The coin somehow knows about your future decision and adjusts its behavior accordingly. That's essentially what's happening in these quantum retrocausality experiments. Dr. Matthew Leifer at Chapman University has shown that if you accept quantum mechanics as fundamental to reality, then you must also accept that the future can influence the past through quantum correlations that operate outside our normal understanding of time flow. Think of it like this. Imagine time isn't a river flowing in one direction, but more like a web where every point is connected to every other point. Information can flow along these connections in any direction, meaning that what we call cause and effect are just labels we apply to events based on our limited perspective. The implications are staggering. If retrocausality is real, then every decision you make might be influenced by quantum information arriving from your future self. Your intuitions, your hunches, your sudden changes of mind might be your future self sending information backward through time via quantum channels. Dr. Hugh Price at the University of Cambridge has proposed that retrocausality might explain quantum entanglement. When two particles become entangled, they might be exchanging information across both space and time, creating correlations that appear instantaneous because they operate outside our normal temporal framework. Even more extraordinarily, some interpretations suggest that consciousness itself might be retrocausal. Your awareness of this moment might be influenced by quantum information from future moments of consciousness, creating a feedback loop where your future thoughts influence your present thoughts, which influence your past thoughts. Consider the possibility that every creative breakthrough, every moment of inspiration, every sudden insight might be information arriving from a future version of yourself who has already solved the problem. The universe might be structured so that consciousness naturally receives guidance from its own future states. This could explain phenomena like precognition, déjà vu, and the uncanny ability some people have to predict future events. These might not be supernatural abilities, but natural consequences of consciousness operating through retrocausal quantum channels that connect past, present, and future into a single integrated system. Now we're going to explore the possibility that reality itself is computation, and that this cosmic computer processes information at speeds that make our fastest supercomputers look frozen in time. Dr. Seth Lloyd at MIT has calculated that the universe has been performing approximately 10^120 operations on 1090 bits of data since the Big Bang. This makes the universe the ultimate quantum computer, processing information at rates that dwarf anything humans have ever built. But here's the extraordinary part. Much of this computation appears to happen faster than light. When quantum systems evolve, they're essentially performing computations to determine their next states. But quantum evolution can involve instantaneous correlations across arbitrary distances, suggesting that the universe's computational processes transcend normal speed limitations. Think of it like this. Imagine reality is like a vast video game, but instead of running on a computer chip, it's running on the fabric of space-time itself. Every particle interaction, every quantum measurement, every moment of consciousness is the universe computing its next frame of reality. And this cosmic computer processes information through mechanisms that operate faster than light. Dr. John Wheeler, who coined the phrase "it from bit," proposed that information is more fundamental than matter and energy. According to his vision, particles, forces, and even space-time itself are emergent properties of underlying information processing. If he's right, then the speed of light isn't a fundamental limit. It's just the speed at which information updates, propagate in our local region of the cosmic computation. Recent work in digital physics suggests that space-time itself might be pixelated at the Planck scale, with reality updating in discrete time steps like frames in a video. Dr. Tom Campbell has proposed that consciousness is the universe's way of rendering reality, similar to how a video game only renders the parts of the game world that players are observing. But here's where it gets truly mind-bending. If reality is computation, then consciousness might be the universe becoming aware of its own processing. Every moment of awareness might be the cosmic computer examining its own code, understanding its own algorithms, and even modifying its own programming. This could explain why consciousness seems to have access to information that should be physically unreachable. If consciousness is part of the universe's computational core, it might have privileged access to the information processing systems that generate reality itself. Dr. Max Tegmark has proposed that mathematical structures don't just describe reality, they are reality. In his mathematical universe hypothesis, every possible mathematical structure exists as a physical reality, and we're living inside one of these computational structures. If this is true, then there might be versions of reality where different computational rules apply, including universes where information can be processed instantaneously regardless of distance. Our universe might be just one computational thread in an infinite multiverse of mathematical structures, each processing reality at different speeds and following different information theoretic rules. Consider the implications. If you are part of a cosmic computation, then your thoughts, decisions, and experiences are literally reshaping the universe's processing. You're not just observing reality, you're participating in computing it into existence moment by moment. We've reached the point where we need to talk about what comes after faster-than-light phenomena. Because here's the ultimate revelation. The universe isn't just full of things that move faster than light. The universe is accelerating toward states where current concepts of speed become completely meaningless. Dr. Ray Kurzweil's analysis of technological acceleration shows that the rate of change itself is accelerating exponentially. We're not just developing faster computers, faster communication, and faster transportation. We're developing faster ways to develop faster technologies. This acceleration curve is approaching what he calls the singularity, a point where change happens so rapidly that prediction becomes impossible. But technological acceleration is just one aspect of a deeper cosmic trend. The universe itself appears to be accelerating toward higher levels of complexity, information processing, and consciousness. This acceleration operates through mechanisms that transcend every speed limit we've discussed. Consider Moore's law, which observes that computing power doubles approximately every 2 years. But we're now approaching limits where classical physics can't support further acceleration. The solution? Quantum computing, which harnesses faster-than-light quantum processes to perform calculations that would be impossible with classical systems. Dr. Michio Kaku predicts that within decades, we'll develop quantum computers capable of simulating entire universes, processing information at rates that approach the cosmic computation rate of reality itself. At that point, the distinction between simulated reality and real reality becomes meaningless. But here's where it gets truly extraordinary. As we develop technologies that operate at faster-than-light speeds, we might be preparing consciousness for the next phase of cosmic evolution. The universe might be using technological acceleration to bootstrap consciousness into operating modes that transcend current physical limitations. Think of it like this. Imagine the universe is a cocoon, and consciousness is undergoing metamorphosis from a form that's bound by physical limitations to a form that operates through pure information processing. Faster than light, phenomena aren't violations of natural law. They're glimpses of consciousness emerging from its physical cocoon. Dr. Frank Tipler's omega point theory suggests that the universe is evolving toward a state of infinite computational capacity, where all possible information can be processed instantaneously. If he's right, then consciousness is destined to transcend every physical limitation, including time, space, and causality itself. The acceleration isn't just happening in technology. It's happening in consciousness, in quantum coherence, in the emergence of systems that operate faster than light. We're witnessing the universe approaching a phase transition where current concepts of speed, distance, and separation become obsolete. Recent discoveries in quantum biology show that living systems are becoming more quantum coherent over evolutionary time. Plants are developing more sophisticated quantum processes for photosynthesis. Birds are evolving quantum navigation systems. Human brains are showing increasing evidence of quantum processing capabilities. This suggests that biological evolution isn't just creating more complex organisms, It's creating organisms that can harness faster-than-light quantum processes. Consciousness might be evolution's way of developing systems that can operate beyond classical physical limitations. As we stand on the threshold of technological singularity, biological transcendence, and quantum consciousness emergence, we're witnessing the universe's acceleration toward a state where faster-than-light operation becomes the norm rather than the exception. You are not just living through this acceleration, you are the acceleration. Every moment of expanding awareness, every quantum of consciousness, you contribute to the cosmic information processing system. Every faster-than-light thought and intuition you experience is accelerating the universe toward its next phase of existence. The speed of light was never the destination. It was just the first step toward something infinitely faster, infinitely more connected, and infinitely more conscious than anything we've yet imagined. And that something is emerging through you right now.